All right, so let's do this one. This one we do exactly like we did problem number 5. So there were, on the last one, there were a lot of good questions as we were going over the video in class, and now I'm in a different class and we're recording it. This is called the inflection point. Now, you guys will call it the center. I don't care. I mean, technically it's an inflection point. Inflection point just means where it changes the way that it curves. So up to this point, it curves down. After that point, it curves up. Do you see that? This is always going to be H, comma, K. And you guys have been calling it the center. And it's like we've been using HK for the center and for the vertex and all that stuff. So anyways, I'm going to list H is equal to 1. K is equal to -1. And then the last thing I need to figure out is the B. But we don't know what the B is. Also, I have an X, and remember, G of X is the same as Y. So the other question that was asked is, Mr. Adams, does it matter which X and Y we pick? The answer is no. Last time we picked the ones on the top, we'll pick these, -3 and -2. The other question that was asked was, why do we need an X and a Y? Well, because when I plug in an X and a Y and the H and the K into my formula, it's going to leave me with nothing but numbers, -3 and -2. Nothing but numbers, and then one variable, in this case, B. So remember, this is Y equals the quantity 1 over B times the quantity X minus H cubed plus K. So now I'm going to plug in what I know. Well, Y is equal to -2. Where did I get that? I got that from the graph. Okay. And I just wrote it up here. Then I have times the quantity 1 over B. X is -3 minus H, which is 1. And all of that is cubed minus 1, which is K. So let me recap in case you're wondering. I got, wherever there's an X, I put -3. So here's an X, I put a -3 in its place. Wherever there's a Y, I put a -2. Wherever there was an H, I put 1, right? So there's an H here, I plugged a 1 in. Now notice, this is going to confuse some people. The original formula has a minus sign. Make sure you include that, because if H is negative, then you minus a minus and it becomes a plus. Same thing with K. I've got K over here. I put plus -1, or you could just say -1. One of my professors would lose their minds if they saw me interchange negative and -1 and the way I say it. But honestly, you guys are in high school. As long as you're plugging in the right stuff and getting the right answer. If you are ever going to get a degree in math, there is a difference, but we won't get into that today. So I've got this cube. I'm going to have to take the cube root at some point in time. So I need to start moving stuff away and doing some stuff with the numbers. So the first thing that I'm going to do is I'm going to add 1 to both sides. Okay. When I do that, -2 plus 1 is -1 times all this stuff. What's -3 raised to the, or not raised to, what's -3 minus 1? -4. Okay. Now, here's the tricky situation. Here, I need to take the cube root of both sides. Now, why am I doing that? Because I got to get rid of this cube. So remember, to take the cube root, you put the index 3 here. Probably most of your life, you've never put a number there, because mathematicians are lazy. If there isn't a number there, it's implied that a 2 is supposed to go there, and we call that the square root. We're undoing squares. But you could do any power. You could do the cube root, you could do the 4th root, 5th root, the 100th root, okay? And so that little number goes here. And so what we're thinking, this cube root undoes this, and on this side, I just get 1 over B, okay, times -4. That's it. Okay. And then over here, I've got to take the cube root of -1. Now, we're going to do this on the calculator. For the first half of the school year, I said you can't take the square root of a negative number, but you can take the cube root of a negative number. So let me show you something. If I say -1 cubed, that's -1 times -1 times -1, yes? Yeah. What's -1 times -1? Nope, guess again. Positive 1, right? Negative times a negative is a positive. I'm going to bring this down, and I get times -1. What's 1 times -1? -1. So the cube root of -1, so we're undoing that, is actually just -1. Now, to verify this, you could do that on the calculator. I showed you this once before. I'm going to zoom in on this. I'm sorry if you were in the middle of writing stuff down. Write faster. So what you want to do to get to the cube root thing, I amuse myself. Hit math. Okay, see the little cube root thing there? So I'm going to scroll down. And by the way, remember I said you could do the 10th root or the 4th root. If you choose 5, that gives you the option. I'm going to choose 5 just so you guys could see. And you put whatever number you want here. Here we're taking the cube root. All right. So now I'm going to plug in -1, and the calculator will find the answer. Okay. Does that make sense? Okay. So now to do the math, this is an interesting phenomenon. I have b in the denominator. So first is first. I'm going to divide both sides by -4. Okay. These cancel, and I get 1 over 4 is equal to 1 over b. Now, this is called a proportion. So what you need to do to solve a proportion is you just cross multiply. So what's 1 times b? B. 1b. We don't need to write the 1 down. What? And we set that equal to the other cross product. What's 4 times 1? 4. That's it. We're done. B is equal to 4. So now, what is my equation? No, well, yeah. So it'd be g of x. So we'll say g of x is equal to 1 over b, which is 4, times the quantity x minus h, which was 1, cubed minus 1. Now, how can I verify that, you guys? Put it in the calculator. All right, we'll put it in the calculator. So I'm going to go, let me clear this out. So I'm going to start my parentheses. I'm going to hit math, put in my little fraction thingy, 1 over 4. Oh, no, wrong one. X minus 1, yes? Raised to the 3rd power. Oh, yeah, I forgot. I got to put a second set of parentheses. Oh, no. I got it. Parentheses. There we go. Woo! That was a close one. All right, and then minus 1, right? So now, when I do this minus 1, basically I just need to look and see. Let's look and see. I need to make this smaller. Let's see if those points are on the graph. So the first point is -3. When x equals -3, -2 is on the graph, yes? The next one is when x equals 1, y equals -1. This point here is this point here. And then when x equals 5, y equals 0. So I'm gonna make that large and zoom in and take a picture of that, and we'll post that in there so we can see. But basically, my equation that I created goes through all 3 points. So that's the correct one. Yes, you have your hand up. You got a question?
Maybe we will see equation after solving b. I noticed that we didn't put the x and y in the equation as well. We just left gx and x alone.
Yeah. Yeah, that's a good question. So yeah, we leave the x and y out because we're trying to solve the equation. But in order to solve the equation, we find one x and y and plug it in so we can isolate the a. But we want this formula that we created, basically when I put in any number for x, it'll spit out the y value, which was the end goal. Okay? Yeah, we did that on purpose.